Okay, welcome to back to my channel. And in the previous lecture, I have solved up to question number 12 according to my slide. And this time, I am continuing the remaining one, question number. Sorry, the first topic of DBMS, and then I shall continue with the second topic of SQL. So, question number 13. The question is saying that given the basic year and relational models, which of the following is incorrect? An attribute of the options are: an attribute of an entity can have more than one value. An attribute of an entity can be composite. In a row of a relational table, an attribute can have more than one value. In a row of a relational table, an attribute can have exactly one value or a null value. We have to find the incorrect statement. So we start from the option A. In option A, an attribute of an entity can have more than one value. Obviously, it is true because in ER and relational models, obviously multi-valued attribute is applicable and it is legal. An attribute of an entity, option B, can be composite. It is also true. Option C, in a row of a relational table, an attribute can have more than one value. Now, relational model and ER model are something different. Okay. In relational table or in relational model, you can say, we cannot allow more than one value or multi-valued attribute in a table. Okay. So option C is incorrect, obviously. And option D, in a row of a relational table, an attribute can have exactly one value or a null value. I think it is incorrect also because it is saying that in a relational table, okay, but in relational table, multi-valued attribute is also applicable along with null values. So D is also incorrect. The explanation is like that. Near model attributes may be of multi-valued and composites, but in relational model, every attribute value is atomic. This basic property of first normal form. Hence, the statement given in C is correct with respect to the question, and this is the answer. Okay. Second question of this video, question number 14. Consider a relational table with a single record for each registered student with the following attributes. Okay. Registration number, unique registration number of each registered student. UID, unique identity number, unique at the national level for each citizen. Okay. Bank account number, unique account number at the bank. A student can have multiple accounts or joint accounts. This attribute stores the primary account number. Okay, we can assume it. Name of the student, hostel room number of the hostel. Now the options are: which of the following options is incorrect? Bank account number is candidate key. Second, B, registration number can be a primary key. UID is a candidate key if all students are from the same country. So this option attracts me more and the most, you can say, because when every student belongs to the same country, UID obviously will be a candidate key. There will be no other things. B, if S is a super key such that S concatenation of UID is null, then S union of UID is also a super key. Okay, so if S is a set and concatenation with another set UID is null, that means there is no common attributes between S and UID. That means UID, a single attribute, is not part of the set S. Then the union of S and that set UID is also a super key, obviously, because any key is a subset of super key, may be proper, may be improper. So according to this, D is also correct. Now B, registration number can be a primary key. Obviously, in a database of an university, as per the question, it is written as unique registration number of each registered student. So whenever the table we are maintaining, the registration number that we shall put will be unique for each and every student, and it will be a primary key. Okay. So whenever it is a primary key, it will be a candidate key. Now, option A, bank account number is a candidate key, but a lot of constraints are there. A student can have multiple accounts or joint accounts. So, two students may have same account. For example, it may not be true, but twin sister open an account jointly in a bank, and they both keep the same account to the university. So, bank account number will be same for these two students, and they actually admit to the same university. So obviously it will not be a correct statement. So option A will be an incorrect statement as per the question. The explanation is same. I cannot re-explain the things. Bank account number is a candidate key is an incorrect statement, and option A is correct. Second question, as per my slide, it is question number 15 and came in late 2005. Two entities, hotel room and parcel, are related to them by relation lodging, and the question is like that. Consider the entities hotel room and parcel with a many to many relationship. They've already told lodging as shown below. Okay. If we wish to store information about the rent payment to be made by person occupying different hotel rooms, then this information should appear as an attribute of. Okay, so they introduce a new attribute that is rent payment, and they try to find out which entity or which relation will take this attribute in its table. Okay, now the thing is, whatever it is, 1 is to 1 or 1 is to m or m is to n, the cardinality hotel room and person, the two entities, can be differently treated. That means a hotel room can be shared by many persons. A person can stay in different hotel rooms. As per my explanation here, this is the thing. So a person stays in many hotel rooms and hotel room is shared by many persons. Rent payment cannot be an attribute of person as the person may stay in multiple hotel rooms and it is associated with both the person and hotel room too. So if I say I say an attribute rent payment that cannot be alone attribute of hotel room as it is dependent on different persons too. Example, how they will share the rent. Hence, or therefore, rent payment must be an attribute of the relational logic. Okay, we cannot ignore this kind of attributes, which is part of the relation. Okay, so the next topic is relational database querying with SQL. I'm starting with this topic, and the question that we can start um, from the recent question first we are discussing, and then we can go to the previous questions, the old one. So in 2025, one question comes like that is shown in front of you. Consider the following relational schema. There are one, two, three entities. Students, roll number, the data type is integer, the name, age, and CGPA. Course, course number, course name, credits, enrolled, another entity, or the student will enroll for the course. So the student's roll number, course number, and the grade what the marks the student has got will be listed. The question is, which of the following options is our correct SQL query or queries to retrieve the names of the students enrolled in course number, that is course number 1470. So specifically they have told the course number 1470. Okay. So we have to check each and every options and we have to say which options are correct. In this kind of questions, some questions in GATE, multiple options are also correct. That's why they have told that which of the following options is slash R. So multiple options may be correct, not only one. Okay. So we have to check each and every options then. We cannot check only one. Sometimes students do it due to lack of time. But questions sometimes be far. So that's why we have to check each and every options. That's it. So option A, select s.name from student S where exist student star from enrolled E where E dot course number equals to 1470 and E roll number equals to S dot roll number. So first of all, we want to think that there is an inner query and then is an outer query, and these are joined by the names by function exists. And this kind of function exist, not exist are Boolean functions. They return always true, either true or false. Okay. So I have to check the inner query. I have to check the outer query. And whenever I have to check the outer query, we have to think about that. That whenever we are checking the outer query, Each and every attribute of the outer query will be taken as an input in the inner query, and they will be checked according to the constant given in the inner query. And hence, select s.name, option A, from students is or exist student star from enrolled E, or e.course num 1470 obviously, and e dot roll number equals to s dot. So e dot roll number equals to s dot number. So just join condition, and we can ignore it. E dot course number equals to 1470. We can ignore it because the question is given like that. Okay. So what we can say that if the inner query returns something, then the outer query will say yes because the function is exists, and the explanation for this I can give. The exist query equals to this boolean. So a student entry which refers to the course with the course number 1470 is passed to the exist query, only returns two values. So option A is correct. Obviously it is correct. Option B, select x.name from student size or size of. We should not read next because size of function, if I go to the explanation, the size of function is just valid for C or C++ language, not valid for SQL. So option B is completely incorrect. You should not consider it. Okay? Option C, select s.name from student is or 0 less than something something. So here maybe the student will be little bit confused about the left hand operator as a numeric value 0 and the right hand operator is a query. But don't be confused because it is allowed in SQL as well as in C++ concept also. That is 0 less than some query, select count star from enrolled E or E dot course number equal 1470 and E dot roll number equals S dot roll number. So the condition E dot course number 1470 as well as the condition E dot roll number equals S dot roll number is the condition for the joining other the constant given in the question 1470. So if we return something and it is less than greater than 1 a 0, then obviously the student name will be printed. So as per the question's requirement, it is correct. As per the explanation also, it is correct too. In option D, natural join is there. Okay. In option D, natural join is there. Natural join means the common attribute between two relations or two entities as per the relational model. The value, if they are same, then we can say the attribute will be returned. Hence the condition of is internal true in this case, the E dot roll number and S dot roll number. Then it checks the course number. Obviously, that is 1470. That condition is given here. So sorry, here. So option D is also correct. The question answer will be A, C, and D are correct. So okay, here I stop the video, and up to this of the second topic I have covered today. The next questions we shall discuss in the next video. Thank you very much.